The revelation of a new exoplanet has stargazers energized that it very well may be, for sure, indications of something going on under the surface. For quite a long time, the fantasy about finding life past Earth has intrigued humankind. Because of the James Webb Space Telescope, that fantasy could before long turn into a reality. The telescope has uncovered an intriguing secret in Proxima Centauri, the nearest star framework to us. In the midst of its planets, Proxima b stands apart with weird counterfeit lights, leaving the logical local area perplexed and captivated. Could this be the hotly anticipated evidence of intelligent life past our planetary group? How do researchers determine if these lights suggest the presence of intelligent life on Proxima b? Go along with us as we dive into how the James Webb Telescope just distinguishes city lights 7 trillion miles from Earth. People have forever been intensely inquisitive about the mysteries of the universe. Through mechanical advancements, our natural drive to investigate the Earth and sky keeps on pushing us. After thousands of long periods of development, Earth remains the main planet that we know to have life. As such, the age-old question endures: are we the main occupants of the universe, or are there civilizations concealed among the stars, simply pausing for us to track down them? To track down the response to this troublesome inquiry, two American cosmologists, Jill Tarter and Thomas Pearson, began a venture called the Search for Extraterrestrial Intelligence, SETI, in 1984. This not-for-profit attempt intends to filter through infinite space, zeroing in on spaceborne radio transmissions. These radio waves are equipped for voyaging monstrous separations, and are the primary means for potential extraterrestrial correspondence. To this end, 42 radio telescopes found in the core of the Californian outpouring mountains were painstakingly tuned to the frequencies of the universe. These radio telescopes, known as the Allen Telescope Array, were intended to get any outsider signal from space. While researchers have checked the sky for dependable signs over numerous years, to date, there is no persuading evidence of signals originating from an outsider human advancement. However, recent reports from NASA suggest that the James Webb Space Telescope, JWST, may have spotted fake city lights from adjacent planets. Is there any substance to this? Let's figure it out. The successful dispatch of the James Webb Space Telescope is mankind's giant step forward in understanding the universe. The JWST is the most advanced instrument in the historical backdrop of humankind to comprehend what the universe holds. Situated around 1 million miles from Earth, this giant telescope is our window to the earliest times of the universe. It brings the previously subtle observation focuses closer, revealing insights into the arrangement of systems, stars, and planets. Stargazers harness the JWST's capabilities, state-of-the-art cameras, and filters to capture and examine them in mind-boggling colors surrounding heavenly objects. Through the JWST, analysts are ready to separate and gather valuable data about the substance arrangements and actual properties of heavenly bodies in the farthest reaches of the universe. They accomplish this by separating explicit frequencies of light. Beyond simple perception, the JWST investigates and explores the atmospheres of exoplanets for hints of life. Its unparalleled ability to see past the limits of reality has led to some of the most surprising discoveries. For example, through the telescope, stargazers have discovered more mass than previously accepted to exist in the universe, hidden in several masses of worlds. This finding has examined the earlier ideas concerning the layout and extent of the universe. With humankind determining to explore the farthest reaches of the universe, the JWST will be a focal eye in settling the mysteries of disconnected universes and planning for new astrophysical information. Only 20 years prior, the realm beyond our planetary system remained largely unknown and without any trace of known planets. However, astronomers have since revealed over 4,000 exoplanets circling distant stars, a remarkable demonstration of human inventiveness and technological advancement. According to NASA, This inventory might be the tip of the heavenly iceberg, indicating the presence of trillions more exoplanets scattered throughout the universe. In the enthusiastic investigation for extraterrestrial life, scientists keep on looking toward the chance of recognizing alien territories beyond where we have been before. As fate would have it, during the Galileo rocket's excursion to Jupiter, its spectroscopic instrument suddenly uncovered a particular spectral mark that indicated earthbound vegetation. This noteworthy discovery marks the first time researchers have seen a biosignature, the vegetation red edge, VRE. The VRE looks at outsider life distinctively by zeroing in on the manner it reflects light. On account of VE, the JWST is expected to unveil the questions of extraterrestrial conditions. It will do this by cautiously planning the orbital boundaries of possibly habitable distant exoplanets found inside the habitable zones of their alien parent stars. Whenever identified, these V signs could be crucial evidence in the search for intelligent life outside our planet. It will be the beginning of a new venture for us in our quest to discover the secrets of the universe. As sunlight goes through the environmental layers, the broken-down light, which conveys various frequencies, is absorbed by the particles and atoms in these layers. This absorption gives rise to a typical spectral pattern, like restrictive fingerprints that can be interpreted through spectroscopic examination. It is conjectured that when light from a star arrives at a planet, the JWST will be able to distinguish it as it enters the planet's atmosphere. Thus, the JWST could be the key to unveiling the atmospheric composition of distant exoplanets, a fundamental sign of their potential for Earthbound life. Earth-sized planets flaunting atmospheres rich in oxygen, nitrogen, and carbon dioxide like Earth could hold conditions conducive to life as we know it. However, the absence of predicted elements or the presence of unusual mixtures could imply alternative forms of life or even mechanical civilizations. Interestingly, found chlorofluorocarbons, CFCs, which are man-made compounds principally used for refrigeration and industrial purposes, could assist researchers in proving the existence of an extraterrestrial civilization. If the JWST observes such counterfeit particles in the atmosphere of exoplanets, it will open new areas of strength for extraterrestrial activity outside our planetary group. This represents a very intriguing endeavor for astronomical scientists, opening a new door into the climatic organizations of different worlds and the possibility of exotic civilizations well beyond the Milky Way. Certainly, the discovery about existence beyond our planet is characterized by several prospects that go beyond the limitations of natural science. While we often imagine life as we know it thriving in calm environments like ours, the reality might prove considerably more varied and extreme. For example, extremophiles, an intriguing group of organisms predominantly made up of microorganisms, challenge what we understand as a suitable living space. These hardy life forms can easily survive, and even thrive in conditions that are generally described as very severe. Extremophiles can endure even the most adverse conditions, with temperatures up to 250 degrees Fahrenheit and pH levels under 3. They are amazing examples of the toughness of living things under difficult circumstances. As such, the limitless dynamics of the universe and the countless conditions associated with it let us know that our quest for extraterrestrial life should be broad. However, while reference planets resembling Earth and orbiting around stable, sun-like stars provide valid potential opportunities, we should also contemplate alternative scenarios. Prime candidates for investigation might include exoplanets orbiting red dwarf stars and dwarfs, which are more abundant in the universe. Despite their lower brightness and cooler temperatures compared to our Sun, these stars offer great opportunities to explore the potential for life in different conditions. The long life expectancy of red dwarf stars provides ample opportunity for the slow, complex cycles of life's emergence and evolution to unfold. Found approximately 40 light-years from Earth, the TRAPPIST-1 planetary system is the prime focus for the James Webb Space Telescope, JWST mission. This stunning system consists of a faint red dwarf star and 7 Earth-sized rocky planets circling the tranquil red dwarf star. 3 of these identified planets are designated as habitable planets and are likely made of water on their surfaces. Although it is smaller and cooler than our Sun, the TRAPPIST-1 star emits a gentle and Earth-like light that is suitable for supporting life on its orbiting planets. Among the different stars in the cosmic region, Proxima Centauri rises as a reference point of potential. At a distance of just 4.25 light-years from the Sun, Proxima Centauri is the closest star to our own. This star can be seen in its faint gleam, barely noticeable amid the darkness of the night sky. However, its weak radiance implies that any habitable planet circling it should keep a close distance. The distance of any habitable planet to Proxima Centauri should be approximately 20 times closer than Earth is to the Sun. Without fulfilling this condition, none of its planets can support life-supporting circumstances like our planet. In an enrapturing discovery on August 24, 2016, cosmologists found a planet with 1.3 times the mass of Earth situated inside Proxima's habitable zone. This Goldilocks-like region offers a delicate balance of light intensity perfectly suited to melt ice for water and potentially sustain the seeds of life. Proxima b is a galactic Catch-22 circling around Proxima Centauri, its host star. This planet, which is surprisingly just 4.6 million miles from its small red star, has many circumstances undermining its ability to support life. Proxima b is exceptionally close to its host star, Proxima Centauri, which exposes it to strong solar winds that can strip away its atmosphere and make it barren. However, notwithstanding these numerous severe conditions, Proxima b basks in the illumination of its small star, receiving sufficient sunlight to maintain Earth-like temperatures where water is in liquid form. The planet's close orbit likely results in tidal locking, leading to one side of the equator being subjected to constant extreme sunlight, while the other experiences absolute darkness. The situation resembles the Moon's relationship with Earth in our planetary system. With just 18% of the mass of the Sun, Proxima Centauri produces a weak gleam by emitting substantially less light.